Look at how to find angle measures using trigonometry and the applications of trigonometry. As a review, this first problem, we are going to start by labeling our opposite hypotenuse and adjacent sides. So looking at the given angle, which is 53, the opposite is x. The hypotenuse from the right angle doesn't have any value there, so I'm not going to use the hypotenuse, and that leaves the adjacent as 7. So the trig ratio that uses opposite and adjacent is TOA, T-O over A. So that means I'm looking at the tangent of the angle 53 and setting that equal to the fraction O over A, so x over 7, opposite over adjacent. I can then type into my calculator tan of 53, and you want to make sure you're in the correct mode, otherwise you won't be getting 1.327 equal to x over 7. And because they are both equal to, the variable is on the numerator, it means that we're going to multiply both sides by 7. And that'll get us a value of 9.3 rounded to the 10th for our x. So it's the same idea with the second problem. We have the given angle, which is the 36. So there's nothing on the opposite side. So I'm not going to be using opposite. There is an x on the hypotenuse, and there's a 19 on the adjacent. So looking at the two sides of adjacent and hypotenuse, that looks like I'll be using the trig ratio cosine, ka, so ka toa. So the cosine of the given angle 36 is equal to the adjacent side, which is 19, over the hypotenuse, which is x. So once again, I need to multiply both sides by the denominator, which is x. So then I can convert, I'll do two things at once. I'm going to convert this cosine of 36 into a decimal. So I'm going to get 0.809x is equal to 19. And then I could divide both sides by 0.809. And I get that x is equal to 23.5 rounded to the nearest tenth. This lesson, today's lesson, is about the given angle being a variable. So we do have the given angle here. I can identify with the opposite and the hypotenuse. There's nothing on the adjacent, so I'm not going to use the adjacent. So the trig ratio that uses opposite and hypotenuse is going to be the sine, SOH. So sine of the given angle, so in this case we've got x as the given angle, is equal to the opposite, which is, actually I'm going to move this over. I don't have enough space, so I'm going to, so sine of the given angle x is equal to the opposite 21 over the hypotenuse 28. So with this one, we are trying to undo both sides with the sine function. We want to get x by itself. So the way that we undo this is called the inverse trig ratio. We're essentially taking the inverse sine, the sine minus 1 of both sides. So we're taking the sine minus 1 of both sides, which means that the right-hand side will become sine minus 1, which is the inverse trig. It's like the opposite of sine. It undoes sine of 21 over 28. Now, when you type this into your calculators, you can just type in, so in calc, in the calculators, this will look like the sine minus 1, which is pressing the second. So on most calculators, these are the steps you'll take. The second and then sine. And then you'll type in the 21 divided by, and then 28. So that's how you enter those values. We should end up with a calculation of about, I wrote it so messily on my notes, but I think it's 48.6. So that's how you tackle inverse trig ratios. The second part of this lesson is on finding solutions to word problems, so applications of trigonometry. So take a moment and read this word problem. As you can see, we've got this ladder that is 12 feet. So when I create a little diagram, if I can do so a little bit neater, the 12-foot ladder is leaning against the house. I'm trying to figure out how far from the base of the house is it placed. So the X should be down there. And it's forming the 68 degrees with the ground. So that 68 is down in the bottom right there. So I've got all the pieces of information. I can just set it up to figure out what the value will be. So this is the opposite, the hypotenuse. This is adjacent. So it looks like I'm using the adjacent and hypotenuse, which is cosine, CAH. So I'm taking the cosine. Let me go back and do the blue again. Cosine of the given angle 68 is equal to adjacent, which is x over 12, the hypotenuse. And when I multiply both sides by 12, well, let's convert this into a decimal first. We have the 0.3746 for cosine of 68. And now when I multiply both sides by 12, I get around a decimal of about 4.5 for x. A lot of students stop here. We're not asking you to solve for x. We're asking how far from the base of the house did he place the ladder. So we do expect you to answer in a complete sentence in some form or another. So the ladder is 4.5 feet away from the base of the house. A 5-foot tall person, sorry, if you take a moment to read the second problem. I don't want to waste time with that. So as you can see, we've got a 57-inch tall person. So if my person is standing straight upright, they're 57 inches. You don't have to include the units in the diagram. I personally like to leave them out. They cast a 36-inch shadow, and that is where typically students make the mistakes. Shadows are on the ground. So the 36 should be down here. I can kind of tell why students think that, or like how they can think that it's a hypotenuse, because they see the head looking down at the shadow, but the shadow is on the ground itself. That's what we measure. We measure the length of the shadow on the ground. And then when we're asked to find the angle formed by the shadow in the distance from the top of the person's head to the ground, so that means, or to the end of the shadow, so that means that's the little X down there. So once again, we've got our opposite, hypotenuse and adjacent. So it looks like I'm using tangent for TOA. So the tangent is equal to the opposite over adjacent. So tangent of X is equal to 57 over 36. And so if I want to undo the tan, you're taking the inverse tan of both sides. So that means that we have tan minus 1. So it's called tan minus 1 of 57 over 36. And when we type this into our calculators, we should be getting a value of 57.7 for our angle. So the angle formed by the shadow and distance from the top of the person's head and to the end of the shadow is 57.7 degrees.